Thank you very much, Niamh. Thank you for inviting me along. It's great to be here. Great also to be talking about this particular topic. My background is in the commercial sector. My background is in IT as well. I'm not a bioscientist or anything. So standardization and working at scale are big things for me. And of course, I'm now working in a research institute where there's as many ways of doing things as there are people, right? So this is a good topic to talk to. So I've been working at the Sanger Institute for 3 years now. My role specifically was set up particularly to bring the core IT functions together with the core informatics functions. So I'll be able to talk a little bit about that evolution as well. I'll talk about, well, I'll first of all give you a little bit of background to the Sanger itself and talk about the informatics side of things there, particularly about our strategy and our vision. And then I'll pick up on a couple of key topics, specifically around things like trying to bring more standardization to communities that are there by their very nature to be innovative, and also some of the challenges of working to scale as well. But before I get into the detail of it, I did want to cover off a little bit of background to the Sanger itself. So the Sanger is just over 20 years old, and I was chatting to Nat earlier, and she was telling me about how the journey of genomics fits with her personal life journey. We've, funnily enough, the Sanger was instituted basically on the Human Genome Project, and it contributed hugely to it. We now are set up into 6 separate scientific programs. That centers around programs like human genetics, cellular genetics, parasites and microbes. We've recently started a program on Tree of Life, which aims to sequence every single species in the UK and Ireland, which is over 70,000 species. So as you can get a sense, we operate at scale, and we might we focus a lot on data generation from the science. I put some stats on the left of that chart there, and it's worth reflecting on when one prepares for a presentation like this and one gathers some stats on your own work area. I didn't realize, but we sequence about 11 trillion DNA bases every day. I mean, it's a massive undertaking. We have around 1,300 staff in our base in Cambridge. And of those, we have about 100 informaticians. And that's people who would call themselves informaticians. I'm sure it's the same in your own areas, where practically informatics covers every single aspect of doing science. To give you a sense of scale of our IT, we run most of our work on-prem. We have a data center. We have about 32,000 cores for scientific compute, and of the order 90 petabytes of data. We do love data. In fact, I'm doing a presentation on Wednesday at ABACBS, particularly on data, so I'll talk to that a little bit. I guess one of the USPs about the Sanger is doing science at scale. And as a consequence, it requires us to be quite structured about how we are organized. Okay, I hope you can see this all right. Maybe a difference in PowerPoint values, right? But I've tried to capture what we call our value chain in the Sanger Institute generally, and it goes from, on the left, what we call sample to data, through to data to insight, and then insight to outcomes. And standardization is a key part of getting volume through that kind of flow. So just going through them in turn, the sample to data side of things is where the wet lab work happens, and it's wet lab work at scale with the scientific staff, and the production coming out from the scientific operations side is largely about DNA sequencing or other wet lab work, maybe cellular type work, and we try to focus on standardized data products with non-QC regime. We do have new assays that come through. We have new instruments that come through. So there's always a degree of evolution on that side of things. And then in the middle section there, which is more into my world, which is about how do we extract value from the data. So that covers off the kind of techniques that you can see there. And part of my job is about making sure that our informaticians and bioinformaticians have the tools and platforms they need. And then on the far right, which is very much into the faculty side of things, that's about actually gaining insight from the outcomes. What scientific questions are we addressing? And the reason that we talk about outcomes is it's not just about research outputs, it's about what value we bring back to society and human health generally. And of course, although I've put this as a simple flow, in actual fact, it's iterative, isn't it? Because it requires new scientific questions that feed into the operations that we have. I thought it'd be worthwhile just giving you a little bit of a view on the kind of structure that we work to. So this is my organisation. It's specifically entitled Informatics and Digital Solutions, and the solutions thing is quite important, because to have everyone in the organisation geared up for helping the scientists solve problems is quite a key thing for us. I would call out well, you can probably see here, there's just in terms of the structure of it, the far left is largely new for us, right? Or at least for this particular organisation, to be working very closely with the scientific community, because it's not just about what the scientists are trying to achieve, right? It's also about what new tools, new IT, new techniques, new approaches that we as a community can bring to the table as well. The Pipeline Solutions organisation in particular is there to run the vast bulk of our workflows, and that includes supporting some of the tools that get used by the research community worldwide, like SAM tools and HTSLib. Also supporting GA4, GHNAT, right, in terms of the standards in genomics there. And Science Solutions as well. I'm doing a presentation on Wednesday where I'll talk a little bit about some of the work there. Now, this organisation, right, is the central organisation. Each of the scientific programmes that I mentioned have their own informatics teams, but they tend to be quite small, so maybe about a dozen informaticians in each of the programme areas, and they rely on the central function to be supporting them, but also taking on responsibility for some of the tools that have been generated locally, as it were, and starting to get maximum value out of them across the organisation. And I'll touch on that in a later slide. Okay, so no presentation like this would be complete without at least some kind of notion about what our strategy is. I guess the important thing is to have a strategy, right? Because it's a great way of flushing out what you might call resistance in the organisation, where people want to be able to do their own thing without being bothered fitting in with the more strategic directions of the organisation. I guess a key part of this is about the Sanger as an institute recognising the increasing importance of bioinformatics to deliver on the mission of the organisation, and being able to use a strategy like this to properly invest in that. I've called out a few challenges on the slide that hasn't really come out too well here, but we seem to have 4 of everything in the Sanger, regardless of what it is. We've got 4 of everything, and sometimes that's okay. It's other times not so when it comes down to getting value for money from investments. We do carry technical debts. You don't run an organisation that's over 20 years old without increasing layers of technical debt. So if anyone can program in Perl, I'd be very interested to talk to you later. And that's also dealing with the challenges of like spatial data is just taking off like Bilio. I don't know how it is in your world, but it's a massive thing for us. So lots of new data modalities coming through. So the challenge is to take that and turn it into a machine that can really deliver for the science. The standardize, simplify, and automate piece absolutely plays to how we do things at scale. But I think I've been around long enough to know that that's just part of the story. There's still the aspect of giving the scientists at the leading edge the freedom and the tools to properly innovate and use the tools that are best suited for them. And another challenge I have in my world is to kind of free up some of the space free up some of the time and effort that's spent looking after existing tools to help us get into the new world. I think Arthur talked about AI and machine learning. Those are the kind of things that we need to be spending more on. We do make use of the cloud, but not to the extent that some others do. We run our own data center, and largely that's because we have very predictable workloads in the Sanger, and we do it at scale. So having had a look at public cloud, at least, it's quite an expensive option for us. We do, however, run a private cloud, and we're at that scale where we can do that, and that seems to work well. Our use of public cloud is generally around kind of new and niche sort of applications that we can pick up and get going quickly. As part of the communication of our informatics strategy, we're trying to emphasize a number of points. On the far left of that chart, one of the key things that we're trying to emphasize is the interplay between great scientific ideas, being able to do science at scale, and that in itself introduces a degree of rigidity that sometimes doesn't help, but also the informatics underplaying it. And we're increasingly adopting agile approaches, if you're familiar with agile methodologies. And that's not just for doing the informatics, that's also about how we do the science, right? I attended a presentation by a chap called Ewan Burney, who heads up the European Bioinformatics Institute. And he kind of shocked people in the room by saying, the first thing that you need is a project manager, right? That's what you need, because the projects that we run are of a scale where that's the first thing that you get in place. You get in place the plans and the plans and the structure. So I guess I'm trying to bring out some of the tensions between doing things at scale whilst at the same time being innovative. I'll talk a little bit about later about the people agenda here, but in the UK, we were massively hit by Brexit, where we saw many of our staff head back to continental Europe, and also by COVID, where firms were recruiting IT staff like anything as they themselves got online. So for us, there's a certain element of generating our own. So we're very active about talent in terms of the acquisition, the development, and the retention of it as well. It's a big thing for us. And one of the nice things about running a central function is that when we choose to invest in certain platforms, we do it at scale. And sure enough, the scientists can go their own way if they want to do something different. But if we get the 80%, then generally that's good enough. And it does attract people onto the platforms that we have. So I wanted to talk a little bit about some of the ways in which we're able to, as it were, get best value out of some of the technologies that come from our programs. So this is situations where a program is addressing a specific scientific question. They're adopting new tools, developing their own tools, building new platforms. And on the kind of left of this curve, it shows you the kind of evolution of technology. This isn't specifically to do with bioscience. The curve on the left is called the Abernathy curve. And it talks to how, as new technologies emerge and evolve and get adopted, they themselves undergo a transformation. So on the left, the top curve that you can see on the scale there shows the amount of effort that gets devoted to developing the technology. Let's say it's a new genome browser or something like that. A lot of focus on getting the right features, the right functions in order for it to be useful to the science. But as it evolves over time and you get more towards the right-hand side of that curve, it changes. The focus for that particular product is now more about lowering the cost to serve, making it easier to use, easier to adopt, making it more usable. And in the Sanger, we have lots of stuff on the far left, where the scientists are creating lots of new tools and techniques to support new assays and tackle new questions. But over time that evolves. And the central IT function are the function that pick up the right-hand side of that. So my team are becoming well used to working with the scientific community to effectively extract the key platforms and tools that could be used right across the whole institute. And I can talk to a number of examples on that. We'll maybe cover that on Wednesday at my presentation. I've entitled this Communities of Practice because that's largely what it's about. We're not in the business of forcing scientists to adopt particular approaches. It's about building communities where the communities themselves, from a grassroots basis, can help formulate what they want specifically. So there's an element of encouraging that, but not forcing it too much. And that touches then on the right-hand side of it, of this curve. So there is actually quite a lot of science around what it is to work with communities to help them help themselves. So I'd recommend Wenger's dualities as a useful topic, because we are often in the situation where we're trying to encourage people who have their day job, and we're encouraging them to share, and that involves time and effort on their part, and being able to kind of sell that across to individual communities is quite a key thing. And we set up a number of communities of practice to do exactly that, but we've done it on the basis of getting the grassroots side of it going first, and then starting to bring in central support in the way of organising, scheduling, and the like to help them move it across. And the key takeaway here for me, and again we were talking about this over coffee, is it comes down to people. Science is a human endeavour. It's a people business. And be able to understand people's motivations, where they're coming from. I think Rob touched on this in his comments on the panel. Understanding their constituencies, what they're trying to achieve, and being able to demonstrate that you can help them move forward. So just to wrap up, I hope I've given you a sense of the Sanger as an institute and trying to operate at scale, and some of the challenges that come out of that. My role in particular is about not just supporting the scientists to do the work, but helping bring new ideas, new ways of working and collaborating as well. And I hope I've given you a little bit of insight into how we do develop our capabilities and try and build up the kind of communities in the organisation that will hopefully help everyone as we go forward, because that's what we're here for. We're all here for the science. Thank you very much.